Hey guys, maybe we can just wait for a couple of more seconds and we can then start with this workshop. Yeah, I think we can go. So yeah, welcome everyone. This is the full stack NFT dApp workshop. I hope you have good time. You enjoy this hackathon so far. I hope that you build some amazing stuff so far. I hope that you finish your work with set of smart contracts, and now it's time for you to develop some decent UI for your project. So this workshop is going to be about that. We are going to build a full stack NFT dApp, fully decentralized, fully in like pure Web3 manner, and we are going to build on top of it already existing NFT smart contracts. So this is like the really nice thing about Web3, where you have like set of smart contracts for some project as like backend, and then you can host as many UIs as you want. Like everything is open source, public, decentralized. My name is Andrej Rakic. I'm a blockchain developer and a new developer advocate at Chainlink Labs. Here's my Twitter and LinkedIn handles. So if you want to reach out to me about this workshop, for example. So let's start with the agenda. First, we're going to create and deploy NFT. Then we are going to code our user interface and a little Q&A at the end. So we are going to start with this Dungeons and Dragons NFT created by Zach Ash on I think it was on Tuesday. It was a code along building an NFT with Filecoin workshop. I highly recommend to watch the video of that workshop. It was really amazing. It's dynamic NFTs with price feeds, with Chainlink randomness, hosted on Filecoin, like pure art of developing NFTs. And this NFT is deployed to Rinkebai testnet, already live, already have some transactions, and now we're going to build a UI on top of that. So before start, what is NFT? So NFT stands for non-fungible token, and it's basically the digital representation, like the proof of ownership of some non-fungible data written on blockchain. And that's it. Like when you have NFT, this is just a proof that you own something non-fungible. For example, that can be art, blog, some music, song, whatever, like something non-fungible. And that's it. Like if your code, your smart contract, to become NFT, it only needs to implement ERC721 interface, and that's it. If your smart contract implements ERC721 interface, it is NFT. If your smart contract does not implement all the functions from ERC721 interface, it is not an NFT. And this ERC721 interface is only a proof of ownership of something non-fungible. Everything else is just like up to you how you're going to create your NFTs. And this is like really awesome Dungeons and Dragons NFT. So we're just now, if you click on this link on Rinkebai, you will have this like page. So this is our smart contract. We're going to build a UI for this smart contract. So once again, I highly recommend to watch the video, the workshop by Zach, how he developed this smart contract, and now we're just deploying UI. So the whole example is available here, andrejrakic.fullstackNFT dApp on GitHub. It's like this is like the whole repo. It's publicly available on GitHub, so you can just clone it and maybe you can just follow up during this workshop. And that's pretty much it. So back to the slides. We're not going to look at this right now. Start with coding user interface. So we're going to create React app with TypeScript. It is really important to make your user interface in TypeScript. Like you have much more control when you write TypeScript instead of JavaScript. We will start with this command. So npx create React app full stack NFT dApp is just the name of our project. It can be whatever you want, and you need to put this flag template.typescript. So I will open my my terminal. We will clear this, and yeah, so we need to be in our home directory. We can just be on desktop. That's really okay for us. And we can use this command. So yeah, we don't need this. And yeah, now this command is going to generate a new React app for us. And we'll have a coffee break, let's say. If you guys have any questions, feel free to questions so far, feel free to write in comments. Yeah. No questions. Cool. Yeah, also, we are going to use UseDApp framework for this UI. So what is UseDApp? It's a really nice, tiny framework for developing Web3 applications. So it's, okay, we're good. It has like all the necessary hooks to handle transactions, to handle reading data from the blockchain, like, yep, how to send smart contract. Yeah, we're going to write this. So cd full stack NFT dApp. We are now in our newly generated React app. And as I said, we are going to use UseDApp. It's like framework for rapid dApp development. It's really simple, has all React hooks, modern stack. It's built with Ethers.js, Web3 React, Waffle, amazing framework. So we will need to yarn add that UseDApp package. So this is usedapp.core, but also I will just install everything that we need so far. So to like save us time. So we will need Ethers project. We will need contracts from Ethers.js, Ethers project. So like we will definitely need to create an instance or smart contract during this workshop. We need Ethers, typechain, and typechain Ether, and types for typechain. So what is typechain? Typechain is a really nice tool, like a really handy tool, which automatically generates TypeScript types out of your Solidity smart contract, out of your Solidity code base. It's really nice when you write your maybe unit test in Hardhat, or when you write your UI, like we are going to do like right now, because with typechain you have all the TypeScript types. So it's like much more type safety to write and deploy your to write and develop your UI using Solidity. So this is the typechain on GitHub. I already explained to you how to install it in your project, and finally we can just do yarn start and run our first React app. So I can just move it right here. It runs on localhost 3000, and that's it. Everything's okay. So right now I with command.t open the new tab in my terminal. I will use Visual Studio Code for writing this React app. You can use whatever code editor you prefer. So with code.dash, I will open Visual Studio Code inside this folder. and boom, with full stack NFT dApp. This is all the folders and files that we have right now. It's a freshly new generated React app. So if I go back, so it says edit src app.tsx and save to reload. So all of this UI is inside app.tsx. So if I go here and remove everything and just say hello Web3 builders, it should be on save. Yep, pop up. So hello Web3 builders. We're now inside our React app. First thing, if we go back to our slides, so we use that. We need to configure networks. So right now, as I said, our smart contract, our NFT, is on Rinkebai testnet. So only supported testnet is Rinkebai. If we are not on Rinkebai, we need to handle that situation. If our user connect their wallet to our UI and, for example, they're using MetaMask and MetaMask by default is connected to Ethereum mainnet, we need to handle these situations because like if our smart contract has one address on Rinkebai, it doesn't necessarily need that this address won't be used on Ethereum mainnet. So we need to stop and prevent interacting with these addresses and with these smart contract instances if we are not on Rinkebai. So to do that, we need to go to index.tsx file, create a little config object, and use this dApp provider, which takes like config as property. This dApp provider is from our useDApp package, and it will wrap our whole app component, like our app function, which is like our basically root of React app. So how to do this? Pretty simple. We'll just recode everything you see on this slide. Pretty simple. So right now, I'll just zoom this a little bit. So I hope you can see this well. Okay, so as I said, we need to go to index.tsx. We need to have this config object. So config will have type config, and it's from useDApp.core, automatically imported, and it's a simple JavaScript object. So as I said, supported chains are like only, it's an array, but for our purpose, it's just, for our use case, pardon, it's just chain ID. Also, you can import it by tab from useDApp.core dot Rinkebai. It's build it and and that's it. And now, as we saw on the slides, we need to have dApp provider. So also imported from useDApp.core. I import this by clicking tab, just tab, and now autofill it. And it's mandatory to have this config object. So config is our config tab. And now I need to close this, that provider, and boom, like this is it. Okay, nothing really happened on our UI because like it's the same, but we have like this wrapper around our React app. So yeah, hello Web3 builders. Okay, let's go back to the slides. This is the most important slide of this presentation, of this workshop. So this is the complete flow of our dApp, and also like the complete flow of most of the modern dApps today. So three main things. We have wallets, we have our web app or dApp, and we have a set of smart contracts. So web app is like a front end. Smart contracts will be decentralized backend, and we are going to use wallets like login, logout flow, and we'll also need wallets to sign some transactions. So you probably already know that, but when you write a smart contract, you have a set of view functions, read-only functions, then everyone can read for free from the blockchain. And there's like another type of functions which updates states. So to update states from state 1 to state 2, we need to create a transaction and to spend some money. And to spend some money or tokens, we need a confirmation from a wallet. We need to sign that transaction. So step 1 will be to connect the wallet to the dApp. Step 2 will be to create a smart contract instance with ABI and smart contract address as parameters. And as I said, connected wallet needs to be on the same network as smart contracts chain ID. So it needs to be on Rinkibai. We need to handle this. And each smart contract has chain ID, Rinkibai for our case, address, ABI, and we use all of this to create a smart contract instance in step 2. And step 3 will be just to call a function or smart contract. That's it. This built-in library, it's a Web3 provider, you will see. It will automatically trigger our wallet to sign transaction. That's it. Like, we're going to use MetaMask, but that can be any wallet you want. It can be Ledger, Trezor, Portis, Wallet Connect, whatever. Like, we just need to sign this transaction in order to call that function or smart contract. And we're going to call a mint function. Like, we're going to mint a new NFT. That's it. So step 1, we need to connect our wallet to the dApp. To connect MetaMask, we'll just handle MetaMask during this workshop. It's like the basic stuff, but you can expand this, like, to have as many wallet types as you want. To connect MetaMask with use dApp, you only need this piece of code. It is simple as that. Like, you need to use this activate browser wallet from use ethers hook, and it will work with injector connector, which MetaMask is, and that's it. And right now we're going to code this. So go back to Visual Studio Code. Okay, we have like this app. So we're going to create a new folder called pages, and we'll call that page like home, for example, like home.tsx. RFC tab creates a functional component. So this is like a quick way to create a basic boilerplate React functional component. I actually use some VS Code plugin to do this, like, really fast, but you can just copy paste all of this, and that's it. You have a functional component. So I'll just code hello from home, for example, save this, and here I'll delete all of this and have home tab automatically imported from pages, save, and yeah, hello from home. Perfect. We need some CSS for this, and I won't code this for like during this workshop. We're focused only on basically on Web3 stuff. You guys are probably much more familiar and better with CSS and front-end stuff than me. So I'll just copy and paste from this repo this CSS. So if I go to pages, home, this is home.css. You see like a little CSS file. I just copy this, paste it here, and yeah, I need to import that CSS file right now here. So import that home.css, class name is home, same as this component, and boom, we have like this nice layout, background color, call it whatever you want. It's just looks a little bit nicer. Okay, so the more important stuff, how to connect our wallet. So inside our home page, we can have some account component, let's say. So To do this, we're going to source, create a new folder called components, and we will have account folder, for example, just component for like connecting your wallet, connecting your account. Inside this account, I can just create account.tsx file, also like RFC tab, new functional component, hello from account. Okay, and inside here, I'll just right now use account. So account tab, boom, hello from account. Perfect. Okay, so we need a button here, like button connect wallet, for example. This is like the purpose of our account component, to have this button. And it's connect wallet, doesn't do anything, but also I want to like this look a little bit nicer. So I will grab this button from this repo. So if you go to source, and if you go to components, you will have a button component. So buttons CSS and button TSX. So we are going to be in components folder, create a button folder. So button.tsx and button.css. So let's start with CSS code, copy paste it. I mean, it's not really important for like Web3 stuff, what we're doing right now, so I can just grab this. And my button.tsx. Okay, so I can comment this. Okay, just to copy it first. So button.tsx. Okay, so this button component renders a button HTML tag, but with additional CSS and has some properties. It has like mandatory prop text, like text of the button, and mandatory prop on click. So this is the function to trigger when you click on click. And also two additional parameters, on click params, if you have some parameters for your on click function, and is disabled, true or false. Like sometimes button can be disabled, and we need to handle this. So this is like our button component, pretty simple. So how to use this? Instead of this button, we are going to use it like this. So tab, we have text, connect wallet, and on click, let's create some dummy function. It can be something like this, alert, hello from button, for example. Yeah, so on click will be dummy function. That's okay, I think. Okay, so if I go back here, now we have like this really nice styled button, and if I click connect wallet, hello from button, that's it. Like we have our button. Okay. So we need to write our connect wallet function. So if we go back to the slides one more time, we need to use this activate browser wallet from use ethers. So inside our connect, inside our account TSX file, so we don't need this dummy function. We need something like this. So we need const use ethers. This is the hook from use dApp core. This is inbuilt hook. So if we go to their documentation, we can search for this, use ethers. Let's see. Yeah, so yeah, here it is. Like this is the built-in hook for using all of the necessary properties from our providers. So we have account. This is the current user account. So if we are connected to to the wallet, it has like the string of the address. If not, it's null. We have the chain ID, so we need to handle if we are not on Rinkiby. A Web3 provider for signing the transactions. We have this active flag. If provider is connected, is active. If there's an error, it's not active. And we need this activate browser wallet. This is the function that will initiate connection to browser Web3 extensions, so only to injected wallets. For example, that's MetaMask. Yeah, we also have this activated function, deactivate, and errors. So yeah, it's not so important. So if we go back here, so we need activate browser wallet, and on click, we need to call activate browser wallet to connect with MetaMask. But also we want to have to handle if we are connected or not. So to do that, there's account, as we said, and we can render something like this. So if there's no account, if it's null, then render this connect wallet button. But if there is, we can just have a little paragraph, for example, connected and account. So let's check this out. So I need to disconnect first. So, okay, so if we click connect wallet, MetaMask pop up, account is this, next, we're connected, boom, we're connected to this wallet address. Perfect. But you see that if you're in MetaMask, you have this shortened version of your wallet address. Like, it's really nice for UI to have this short version rather than this like long string with like your full wallet address. So we can do that by also using useDAP core. So we need to format this address. So we can have function like this. So let's call it format address, and then we can return shorten if address from useDAP account just, or maybe we can paste it like from here. So I mean, don't care. Account. That's okay for the demo, right? And yeah, connected will be right now. Yeah, we need to call format address. Yeah, perfect. Format address, and yeah, boom. We have like this shortened string. It's really nice, like the same as in MetaMask. So that's perfect. If I click disconnect, it disconnects me automatically from my UI. So this is like really nice. Okay, but what if someone has ENS handle? So it would be really nice if our dApp handles ENS, because like it's much more cleaner to have like some name.eth rather than this like shortened address. So fortunately, ethers.js has a function to check if a connected wallet has registered ENS handle. You can register your ENS handle or domain for free on Rinkiby, on like Rinkiby testnet. I did that. So before this workshop, so we are going to handle this like ENS stuff. To do that, we'll first need use state. So const ENS set ENS will be use state, and the type will be string or null or undefined. Perfect. Initially will be null. Yeah, so we can do this inside use effect. So use effect. This is like from my VS Code plugin, like also code sample. So this is like use effect, simple hook. So I will delete all of this stuff for now. I will import use effect from React. And now we will call this function const is ENS, for example, and it will be async because we need to handle this checking. And yeah, so const.ens will be await provider. Our provider is called library inside this use ethers hook. So you see Web3 provider object is called library. So library dot lookup address of account. And we need to handle this stuff from because of the TypeScript. So if there is no account or there is no library, and there is no library, then we can do something like this. Lookup address. If like this. Okay, so we can do if there's no account and there is no library, like this, or if there is account or library, like whatever. It's the same thing. Okay, so this lookup address is from the ethers.js package. It like returns promise as a string, and it will basically you need to enter as a parameter your wallet address. It's a string, and it will check if this wallet address has ENS registered. That's it. And yeah, we are going to set ENS state like this ENS. Yeah, now we are going to do something like this. So if we have ENS, like it's not null, then display this ENS state. If it's null or undefined, then shorten the address of our account, and that's it. Like the last thing we need to actually call this is ENS inside our hook, and yeah, this hook is depends on account and depends on library. So pretty much that's it. Okay, so if I click connect wallet, I will connect my wallet once again. So this is my shortened address. And now if I switch to this account number 2, connect, this account has ENS handle andre.eth. So it's much more cleaner to have this ENS stuff than to shorten this if address. So if I disconnect from this account too, disconnect this account, okay, we have like the address of this first account. So you see BB05. If I disconnect from this account, boom, we have the connect wallet. So this is like really standard stuff to have, like connecting wallet, disconnecting wallet, etc., etc., etc. Okay, so next thing. We need to handle the situation when we are not on the Rinkebai testnet. I said that a couple times before. So if we are, for example, on Coven, we should display some error message to the end user. So if I go, let's say I can wrap it like from home, that's perfectly fine with me. So as I said, so go back to the documentation. We have this active flag, like from use ethers hook. So I can check if provider is connected or not. That's it. So I can do something like this. So I can use active from use ethers tab. Perfect. And I can do something like this. So if there is no, if it's not active, then I'll just display something like this. So error page. I don't care really. And if I'm connected, then I will display this account component. So let's try this out. Okay, error page, perfect. So yeah, so okay, is active account. Cool. Then what we want to do right now. So next is to just let me check if I'm connected. This is not okay. Okay, just page count. Okay, just leave it for now, and we can go back to that later. Okay, just to see what happens. Okay. Yep. I just lost my CSS. Sorry about that, guys. As I said, like CSS is really painful for all developers, I think. Cool, we're good. Connect wallet. Everything's working fine. That's okay. Next thing, when we connect our MetaMask, when we connect our wallet, we need to create smart contract instance with ABI and smart contract address as parameters. So each smart contract has chain ID, address, and ABI. So to do that, it's simple as this, like new contract, address, ABI, and provider. This is library, Web3 provider, and that's it. Like this is all the code we need to create a smart contract instance. However, we are going to create our custom hook, and I'll just explain to you why. So first, step by step, this is the deployed smart contract on Rinky by testnet, and it has like chain ID, like it's for Rinky. It has its own address, and it has its own ABI, application binary interface. So contract ABI, application binary interface, is just a simple JSON, and that JSON helps our front end, our UI, to know how to call from JavaScript or TypeScript some Solidity function. That's it. Like, okay, so we are going to copy this ABI, and right here we are going to create ABIs folder, for example, and new, let's call it Dungeons and Dragons character .abi.json, new folder. I'll just paste it, save it. Okay, just format document a little bit better, it's prettier. Boom, we have our ABI. You see, like it's JSON. That's it. Simple as that. Okay, so we want now to call some view function before like user is connected with their wallet. So it's useful when you're a regular user and you step up to some depth and you want to read some data, or to, as a developer, display some data to users without, if there's no need for you to connect your wallet, then don't connect your wallet, just display that data. And we can display read-only data. So everything from read contract here, we can easily display it without connecting our wallets. So I can display this get number of characters, for example. And to do that, I will need Alchemy. So Alchemy is just blockchain API and node service. It's a Web3 provider with historical data and everything. So with Alchemy, I can register here for free, get my free key, and then I can use this Alchemy key as a Web3 provider for my app. So this is exactly what we are going to use right now. But so first we are going to go to index.tsx once again. And now, as I said, we need read-only chain. So read-only chain ID will be also like Rinkyby. So it will be chain ID dot Rinkyby. That's it. And we need like URLs for this read-only stuff. So we need a provider. So read-only URLs will be for chain ID dot Rinkyby. For Rinkyby, it will be something like this. Like if we are using Alchemy, for example, it will be https eth dash Rinkyby dot alchemy API dot IO version 2, and right now we need alchemy key. So we're going to create this little object, alchemy key. It will be string. So it will be either your like key from .env file, or you can paste it here as a string. I highly recommend to put your keys in your .env files. It's environment variable. It is like only exists on your like where your project is. It's not pushed to the GitHub to any repo. So I highly recommend to store these keys inside your .env file. Although they are free, you know, my key is free, you can take it. I highly recommend for you guys to store it on env. So how to do that? So we are going to have this env.local file. You see how it's grayed out? This is because it's like it won't be pushed to the repo. And if I go to this repo, and here is env.example file. So this is like how our env local file will look like. So we will have React Alchemy key, and I'll just paste my key here. So for you guys, I can just create env local env example file, and it will be your key here. And right now I'll stop sharing my screen to paste my alchemy key here, and then we will continue with this workshop. So give me a second to grab my key. Okay, here it is. Just to make sure that I'm not sharing my screen. This is like really important to have these security concerns. Okay, I think we are good. So back to screen sharing. Okay, you should be able to see my screen. Okay, cool. So button index dot. So here we are going to use process.env dot let's work it right here, react app alchemy key. We're here, so react, or you can paste your alchemy key here, but I don't recommend to put it as a string. So be careful, guys. And alchemy key. That's it. Like we have our config. I need to restart right now my React app to grab these new changes. And yeah, so we need to read some data from our smart contract. So to do that, I will create a counter component. So here, counter and counter dot csx rfc tab, we have counter. So we'll have like, let's say, so here are Dungeons and Dragons, number of characters, cool. So we have number of characters displayed here. Some number of characters, don't care. So I can put this counter above this, all this stuff inside account component. So I can just put it here for you. I think this is okay. Yeah, number of characters, cool. So how to get this number of characters? As I said, we install also type chain. So type chain is a really handy tool to generate TypeScript types for your Solidity smart contract, from your Solidity smart contract. So if I go back to this like example repo, and here inside package.json, there's this really nice command for generating types. So I will just open my integrated terminal to show you guys the magic. So we already have this ABI. If I paste this, so npx type chain, target is ethers version 5. We install types for this version. Outside, like target directory will be source ABIs types. So here inside ABIs folder, we accept to have new types folder, and it will basically grab everything from ABIs folder, which is JSON. So all JSON files from ABIs. And boom, we successfully generated 4 new typings. And it's here. So I can just put these types inside gitignore, because I mean you don't need to push your types like to GitHub. So source ABIs types should be grayed out. Yeah, it is. But we can create something inside our package.json. So we can have like a script for this. For example, we can call it like generate types. And yep, it's this script. And we can just, every time we start our React app, we can just call yarn generate types and then React script types. So right like this, you don't need to push your types folder to the repo. You will have automatically generated for you when you first like ran your React app, which is like super handy with this. Okay, so finally, to have like this counter, so we can do something like this. So we can have like the state number of characters and set number of characters. We will just use useState from React. It will be number or null. And initially it will be null. Okay, so number of characters here, number of characters. Okay, perfect. And yeah, how to set this number of characters? We need to call this function from our smart contract, get number of characters. Okay, how to do that? We need a smart contract instance. So if I go here, we need to create a smart contract instance. We're not going to create it like this. We are going to develop our own hook. And I will show you right now how simple is this hook. I use it all the times in my project, so feel free to grab it, copy paste it, whatever. It's like my gift for you guys. So inside our source directory, we are going to create hooks folder, and then we are going to create use contract.ts file. So be careful with this. Maybe it's something, I don't know, unusual, but it's really easy. So we are going to create custom hook. So to create custom hook, this is the syntax. So our custom hook will be called use contract. And okay, let's start with the types. So it will have like any type because we are using pipe chain. So this any type will extend contract. from ethers.js. Actually, I wanted this to be from ethers project.contracts. Okay, and it will be contract by default. But if we put like some type chain type, some type from type chain, it will like everything will be working fine with this syntax. So I hope this is like clear to you guys. And we need address and we need ABI, right? So ABI can be anything. Address, I like to use address maps. So right now I will create a new folder and call it constant, for example, constants. And new file will be addresses dot TypeScript. Okay. So inside addresses.typescript, we will have something like this. So we need new type called address map. So address map is a simple, like something like hash table, but in TypeScript, in JavaScript, simple JavaScript objects. So we're going to have chain ID, which is number, and for each chain ID is a key. The value will be some string, and this string is actually a smart contract address. So export const, we can call it NFT addresses, for example. We don't care. It will be a type of address map, and this is a JavaScript object. So for our Rinkaby, because we are on Rinkaby, so for chain ID Rinkaby, the address is, just go back to these Dungeons and Dragons, copy this address, paste it here, boom, we have like a really handsome hash table. So it's really scalable. So you can put whatever, chains you want here, different chain addresses, and you can handle them much better than with just provide like you can just provide it like from here, like with strings. So back to our use contract hook. So address map, we are going to use it here, and type address map. And the return will be our type or null. Okay, that's it. It's red now because we don't return anything. We will return it right now. So we are going to return use memo hook. So use memo is a hook. Maybe I can just use something like this. I have this little code snippet. So use memo has like a built-in function and depends on some inputs. And with use state, you generate new objects on each render. With use memo, you don't do that. You have like memorized your objects, and it won't be generated on each render. It will be only generated when these inputs changes. So it's really handy for our smart contract objects because we are not going to like create a new instance of smart contract on each render, for example, with use effect. So this is like much better way to do that. So what we are going to do here is we'll have some function, and yeah, so if address map is not okay, or if there's no ABI, or yeah, we can return null for now. And yeah, we need address. So const address is a string from our address map. So address map of chain ID. So what's chain ID? We need that from use ethers package. So if we are connected to Rinkaby, we are going to have chain ID of Rinkaby. If we are connected to Kavan, to mainnet, for example, we are going to handle that by displaying error page, and we are not going to just initiate this object. So from use ethers package, from use app, so use ethers, we are going to grab chain ID. Simple as that. And we need to handle this. So if chain ID is not okay, it's now, return now. So chain ID, and that's it. So this is our address. So yeah, if there's no address, return null. This is also TypeScript stuff. And now we're going to try catch this. Okay, I'll do this later. So inside our try catch block, we are going to finally have this line of code. So const contract type contract is new contract address API and library, because we need a signer or provider. As I said, in use that's called library. So this is it. And we are going to return this contract. Yeah, if there is an error, catch dot error, and we're going to console error. That's this error. And we are going to return just now. This is okay. And yeah, okay, so we need if address map changes or API changes or library changes or chain ID changes, we need to handle that, and we are returning it as our type. And that's it. Like, this is our use contract hook. I hope this is clear to you guys. This is just a really nice and efficient way to create your smart contract objects. If this is too much for you, but I said you can copy paste this hook from my repo, that's fine. You can just do it like this. But this is a much better way and much more scalable way to do that. Okay, now we have our use contract hook. We can go back to counter. And inside the counter, we need like a smart contract instance. So we can create it like this. So const contract equals use contract. So use contract hook. Why I create this hook? Why just not use like regular use dApp stuff? Because here how they like call contract. So they have like this use contract call function, use contract function, and it's here. I hope you can see this guy. Like I don't like the syntax, and that's only me. Like this is the reason why I created my own hook for this workshop. If this is fine with you, you can just use this also, and that's okay for me. So use contract. Our use contract will have a type of Dungeons and Dragons character API from types. This is like the magic of type chain, and this is that T extends contract equal contract inside our hook. So this hook needs an address map, so NFT addresses, and need ABI. So ABI we can input it like this. So where's our ABI? ABI's folder, Dungeons and Dragons, boom, there it is. So we have like our contract instance, and that's it. And right now we only need like use effect from React, and our use effect will have like this function. So const get number of characters, and it will be async. And get number of characters will do something like this. So if there is a contract, and I'll just do this double notation because this object eventually maybe can be like undefined or null. So with this, I am 100% sure it's not undefined or null. It is the same as like this if there's a contract, but this is like double check for security reasons. We need to have constant number of characters, and it will be right now. We'll see the type. So await contract dot, and we now have all the methods from our smart contract because of the type chain. Really useful. So we need get number of characters. That's it. And this function returns promise with big numbers. So I will make this as big number. Not like this, big number from Ether's project and tab. And now I need to set number of characters. It will be this number of characters, but I need to convert it to a number. And I need to call this get number of characters, and input. Yeah, it only depends on the contract object. That's it. So let's see how this works. Okay, we have 3. So number of characters is 3. If we go to either scan, get number of characters is 3. Perfect. We have like our read-only view method from a smart contract displayed on our UI without connecting user wallet, which is really nice, really awesome. And right now, what left is basically to call some function which needs wallet. So I will just call request new random character. That's the minting function for this NFT, and we're done. So let's have another component and call it mint. Okay, so let's do that like this. So mint.tsx and mint.css. So here new. Okay, we have a mint. We have a mint component, and yeah, inside the mint we can do something like this. So we can have like a button, and text will be mint NFT, and on click we can have also some dummy function for now. Alert low, and yeah, so dummy function. Okay, so we need to import this button, obviously, and that's it. So we're going to put this mint inside our account, so we can do it like here, for example. So when you have like connected wallet, you can just have a mint, and that's it. You have a mint component. So when I go back and connect my wallet once again, and yeah, so number of characters is still there. I'm connected with this wallet, and there's this mint NFT button. So hello. Okay, so let's make this a little bit nicer. So I can have something like this. So if you go to my example, you will see that here are some image inside the assets folder. So we're going to like also add this image, like to make this a little bit nicer. Yeah, so src source assets, and then images, and yeah, so let's find our image right here. So this is a fully working example. Source assets images. I can copy this image, and yeah, this is our current project. So assets, images. Okay, perfect. We have like our Dungeons and Dragon character here. So I can just go back to mint component, and here I can have an image tag. Okay, we're going to make it prettier later, but I can have a source, which is something, and alt text, which can be NFT. So, okay. And we need like a styling, so class name something. So let's start with CSS first. So go back to the example repo, components, mint.css, a little styling for the image. Copy paste this, go back to our code base. Okay, mint. Okay, so this is image. So class name will be image. I just need to import this mint.css file, and sorry guys, this need to be a string, and I need like as a source this image. So import. Let's do syntax like this. So image from. Okay, this is assets, images, and just to not misspell this is like the crucial thing. Dragons dot JPEG. Okay, perfect. And I can use this image here, and let's see how this works. Okay, it looks really nice. So we have like our little knight or elf or whatever this character is. And yeah, let's finally call the minting function. So instead of this dummy function, we need mint. So we need a smart contract object. So once again, we are going to first have const contract. It will be use contract. Type will be Dungeons and Dragons character. And yeah, we need address map, so NFT addresses, and we need ABI. We need to import that ABI. So import ABI from, let's find it. It's in ABIs folder. It's this JSON. Perfect. And yeah, so we need also, let's start typing and we'll see what we also need. So we need signer. So signer object is like, as I said, we need to sign our transaction. So let's go back first to the slides. So this is how we are going to mint our NFT. So we need this signer, JSON RPC signer. It's from our connected wallet. And then we need to create a transaction object and to connect this signer with this and to call just the function itself on a smart contract. So this is like the simple boilerplate code, and we are going to now call this. So signer is JSON. No, it's like this RPC signer type or undefined. So and it's like a library. So we need library from users. So const library from users hook. Once again, we are using this hook really often. So library get signer. Okay. Okay, JSON RPC signer. We can import it from here. I don't know why I cannot see it, but JSON RPC signer is from Oh, actually, it's from there's project.providers. So we need to install that package or not. No, we're not. Perfect. We have it already inside our readers. So it's from this. So yeah, if signer to shut down this this error message, we now need to create a transaction. So const x will be okay. So this need to be async for sure. Await contract dot connect with signer, and then we're going to request new random character. This is the function from a smart contract. So if I go back here, request new random character needs a string. So I will just provide this string here. So name will be something, and we are going to request new character from name. That's it. Okay. If there is chain ID, okay, so we need that definitely from this package, and transaction, we are going to create a transaction hash. So link, it will be get explorer transaction link. So this is from the used app. Basically, you have a transaction, and this is going to use chain ID and your transaction hash, and it will automatically generate that fancy rinkyby.etherscan/transaction hash URL for us. So this is like really useful, like little function from used app. So get transaction link from tx.hash. Actually, it should be like this, and from chain ID. So this is like our link. Okay, so what else? We will definitely need to put this in somewhere. So we can just create a link object. So like this. So div, it's a tag. The ref will be transaction hash, and yeah, so const tx hash, set tx hash, view state, it can be string or null or undefined, can be null for like at the beginning, or just, yeah, that's fine. And quick fix this. Come on. Okay, so this can be this tx hash from our React state, and here I can just set tx hash as this link. So this is nice, and also target will be blank, and rel will be no refer. Okay, that's it. Closing tag and tx hash. Okay, so okay, it's not now, it's just string or undefined. Okay, we'll fix that. Okay, so we have like this really nice transaction ID link, and now we just need to do this. I'll wait a transaction to actually happen. Like wait, okay. And yeah, so we can set transaction hash here as undefined, and we can also disable our button, minting button, during this execution, during mining of this transaction, like to prevent user to do something that is not right. So we can like something like this. So is disabled, set is disabled, and yeah, so this will be your state. It will be Boolean value. It can be for beginning can be false. I think yeah, false is nice. So is disabled, and yeah, so we are going to disable it here. So set is disabled to be true, and once we await everything's okay with this transaction, then we are going to set is disabled as false. And our button will have is disabled. That's it. Like, okay, so this is mint function, and on click params we can paste some string. For example, I don't know, elf. Elf is okay. Okay, so this is it. We need to install this package. This is the reason why this is red. So we're going to go here. Yeah, this is bad. Yarn add providers. Okay, cool. Then retyping, everything is okay. Okay, let's see, this is compiling. Okay, we have some troubles with our typing. Okay, we can make it something like this. Okay, to get rid of this error. This is not the good way, but live coding is always stressful, so we are not going to debug this. We don't have time. So last thing called main function, but this is going to fail because I don't have Rinky tokens. So to get these Rinky tokens, you need to go to faucets.chain.link, and here you have like Ethereum Rinky network, and you can grab 10 test link tokens or 0.1 test ETH, and just you need to paste your wallet address here. So I'll just switch to this another account which has some Rinky thing for our workshop. So confirm. We have this Rinky transaction. If I click here, it's like still pending on Etherscan. Our button is disabled. We have this little loader from CSS, and we just need to wait for our transaction to be mined. So this is not our transaction, and that's pretty much it. So yeah, our UI handled that transaction is success. Now we can again mint some new NFTs. If I go here, it takes some time for Etherscan to grab it, but here I have a success transaction on Etherscan, and I have a new NFT. I spent 0.1 link tokens for this because you already saw Zach's video. It used randomness and get price fit and everything, like really awesome. Awesome workshop. Try it, and that's it. Like we have our fully decentralized Web3 dApp. I just need to disconnect from these accounts, and boom, like this is it. So go back to the slides. Yeah, we have a little Q&A, but before that, thank you all for staying up until the end. It was a long workshop, and as a gratitude for you, you can mint your proof of attendance protocol NFT. So it's NFT workshop, and you need to have your NFTs as a gift. So feel free to scan this QR code, and you will get your free NFT, like for free, like proof of attendance to this workshop. So I will wait a couple of more seconds for you to scan it, and after that, like I will start with the Q&A session, and that's pretty much it. So let's see what's the questions. Dungeons and Dragons. Okay, a lot of questions. Is necessary to use Web3 library? Why not communicate with window.ethereum? Because window.ethereum, it's wrapped inside these libraries, and these libraries handle much better this than window.ethereum, and you have this nasty try and catch blocks and everything. Like, this is the much more this is modern way to connect your wallet, basically. How I can send NFT to a smart contract? You just need to initiate a transfer function, and that's it. Will the source be posted on GitHub? It's on GitHub. So source code is here, full Andrei Rakic, full stack NFT dApp. So this is the code. This is the link. That's it. And yeah, for the end, we recommend for you to scan this QR code and like add a feedback of this and any other workshops. And yeah, that's it for all from me. Thank you again for joining this session, and keep building, and good luck through the end of this hackathon. Thank you, guys.